Hello, everyone, and welcome back to Anthropology 310, Origins of Human Diversity. It's the 25th of September. It is Wednesday of week 6. We are still in our time machine phase, moving forward in time every day, talking today about the first members of our genus, Homo. We are Homo sapiens. We'll talk about Homo habilis, and I brought in some skulls and we'll talk about them. And it's super exciting to me because we've been talking about biology for a long time with a little bit of culture. But from pretty much here on out after today, we'll be focusing increasingly on culture, and after the next week or two, entirely on culture. So that's kind of cool for me as a cultural anthropologist. We'll leave the kind of biological science behind and move forward. We're down here. We are in the we're in the second region, Australopithecus. We'll finish up some Australopithecus, some later forms of Australopithecus today, especially with our cousins who did not survive to the present day with a robust Australopithecus. And then we'll get to Homo habilis, especially with our understanding. We'll finish kind of on this idea of the lower Paleolithic. What does Paleolithic mean? What is lithic? Stone, yeah, paleo. Old, yeah, the old Stone Age, which you might have heard before, as well as the first creation of stone tools. And remember, on Friday, we'll talk about stone tools today, and you'll be like, stupid stone tools. They look boring. They look easy to make. Those Homo habilis, so silly, right? And then on Friday, we're going to give you a chance to see what it's like to be a Homo habilis. We got a bunch of pile of rocks. We're going to go out back behind the anthropology building. We're going to smash them together and see if who is smarter, you or Homo habilis, with your big brains versus their little tiny brains, right? So we'll give you a chance, and hopefully, usually people think, man, it's a lot harder than it looks, which I agree. Okay. So last time we started talking about some of these really early human ancestors, right? If we say that the split from chimps is about 6 to 8 million years ago, we looked at some of these really old stuff, right? The Sahelanthropus or Orontugensis, Ardipithecus, right? These kind of really old 6 to 4 million years kind of things. Before we introduce this concept of Australopithecus, Austrio meaning southern, Pithecus ape, the southern ape of Africa. First discovered by Raymond Dart in the 1920s, and then a whole bunch of these, Donald Johanson and others discovering just a whole bunch of these. And you can just kind of see how many there are. Australopithecus afarensis, Africanus, the Garii, the Aethiopicus, the Robustus, the Boisei. And so that's generally this time period of about 4 million years ago, Anamensis, with things like Lucy, which we talked about, probably one of the most famous, really complete skeletons, as well as kind of Afarensis, the first one found. And we'll be moving forward again in time today. We'll be looking instead, if we were looking at about 4 to 3 million years ago on Monday. Today we'll be looking at this block right here, the time periods as we get closer to present will get shorter and shorter because more stuff starts happening in them, so we're going to take more time. So we're looking at this time period of about 3 million years ago to about just after 2, maybe 1.5 million years ago. And we'll still talk about some of these Australopithecus that were hanging on all the way to about 1 million years ago, right? So we're going to do this. On Friday, we'll do our stone tool lab. And then next week, we'll be talking about Homo erectus, Homo ergaster, these guys here in the 2 to 1 million range. And then finally, the emergence of us, Homo sapiens, about 100,000 years ago, and some of our close relatives like Neanderthals and the Denisovans, right? So last time we talked just briefly about the difference, some of these theories about which came first, big brains or bipedal walking. And what did we decide? Do you remember? Bipedalism. Yeah, bipedalism came first. All the Australopithecus and the like that we talked about last time had relatively chimp-sized brains, maybe, a little bit bigger, maybe, instead of 300, like 350 or even 400 cubic centimeters. We measure cubic centimeters. It's really interesting with mustard seeds, kind of a weird thing, but they're very tiny. And so basically you take these skulls, and when you want to measure the cubic centimeters, you take like this skull, take the hole in the bottom and fill it up with tiny little mustard seeds until it's all the way full, and then you pour them back into a graduated cylinder. And it tells you how many cubic centimeters. That way you don't have to use any kind of I don't know if you're like me, but like calculus, it's really hard, especially like calculating the volume of a uneven sphere-ish kind of thing. So it's much easier to fill it with a physical material than pour it back into something else and tell us how big it is. So we see that bipedalism tends, seems to develop before big brains. And how do we know that something is bipedal? If we only find the head, is there a trick? Yeah, the foramen magnum. Let's see on this Australopithecus africanus. Foramen magnum is right on the bottom, right where we'd expect it to be if it was a biped. And I brought my gorilla example here as well. And you can see on this one that instead of going straight down, your finger doesn't actually fit there. It fits more like this. Can you all see that? So the spinal column is coming out at this kind of angle, and you can just kind of imagine if the spine's like this, it's going to be a knuckle walking creature. Versus if the foramen magnum's down here, it's going to be biped. And again, we can use that really easily. Foramen magnum, these two look very similar. We'll talk about this Boise and this gorilla. But the foramen magnum's in a very different place. So we know this one's an upright walker, and this one's a knuckle walker. If we don't find the skull, what's another way we can tell? What are some other features maybe in the lower part of the body? Pelvis. What? Hips, yeah. Knees, arched feet, feet with a toe that sticks straight out instead of like sticks out to the side like your hand. Right? You can remember that your hand versus your foot. Is that? Shape of the spine. Yeah, shape of the spine, it curves up, right? Versus kind of being like this. All these characteristics, which are little pieces of evidence. And, especially if you're a scientist and you have like a very fragmentary skeleton, you're going to want to use multiple lines of evidence, right? Because a lot of times, here's a famous Homo habilis skull. We'll look at next time. It's very complete. It's remarkably complete for some years ago. But you can see the foramen magnum is like a little bit there, but not really. But we have lots of different skulls that we can look at those, or we can look at the other parts of the body as well. Okay. When we talked about Australopithecus last time. And like I showed you on this chart, there's just a ton of them, right? And I think they're super interesting, especially because they seem to have had what we call radial or radiated evolution. That once Australopithecus and these kind of early bipedal apes like Ardipithecus, once they evolve, they filled a whole bunch of niches in their landscape, right? Some of these became what was known as the gracile Australopithecus, and some became known as the robust. And here's two good examples of a gracile versus a robust. It's not about like the size of the body, right? This one's not like a petite, and this one's like a big, bulky football player. It has to do primarily with the size of the jaw and especially the size of the teeth, right? What do you think a creature with bigger teeth, big, flat, molary kind of teeth, like this guy, what do you think they are eating? More plant. Yeah, plants, rough, tubery leaves and sticks. Versus this one had smaller teeth, the graciles. What kind of stuff do you think they're eating? Grass. Not grass. Small. Yes. Probably scavenging just whatever, right? Like these are ape creatures who were not only eating, they got kind of general dentition. You could eat fruits and you could eat berries, but it seems like at this time they're eating meat, but not actually hunting it, right? Yeah.
If they scavenge, does that mean they eat something that's already dead?
Already dead, yeah.
Like vultures?
Yeah, like a vulture. That's
gross. Yes.
Not a great kind of start to our lineage, but take it where you can get it. If you can imagine, 2 million years ago on the savannas of Africa, we like to think of ourselves, as top dog in the evolutionary pyramid, right? And today we kind of are, right? We cause all kinds of species to go extinct. But back in the day, we were not top dogs, right? We were 3 foot tall little bipedal ape things. There were scary things out there. There were leopards, there were jaguars, there were lions, lots of things, hyenas, lots of things that would like to eat you as well, right? And so these are the things making the primary kills, especially in this kind of Australopithecus era. And after the lions and stuff like that, the hyenas would have their fill. Oftentimes, what part do you think they're going to eat? What's Simba going to eat? The good part, yeah, the steaks, right? Like if you've ever been to like a barbecue, right? The stuff that goes first, the good stuff. And the hyenas are going to come and eat the hamburgers, right? And then what's left for a polar Australopithecus?
The dog and hot dogs.
Yeah, the hot dogs, the bones, the marrow inside, the guts, the leftovers, right? And so, but it's important, right? One of the things about like gorillas, here's my gorilla. They're really big, huge, right? 500 pounds or so. But they're vegetarians. They only eat leaves and sticks and fruits and things like that. It takes them basically all day to eat enough calories to keep their body going, right? And they're pretty small brain, 300 or so cubic centimeters. And they spend like literally from the time they get up. If you're a gorilla, a primatologist studying gorillas, you're like, put on your notebook. Today, gorillas ate. It's most of what they did, right? We humans have big brains. And even in Australopithecus times, we're getting bigger brains. This guy right here is pretty small, 3 foot tall, versus our massive gorilla. This one has a lot bigger brain, 400 cubic centimeters, a little bit bigger. And it takes a lot more energy to power brains than muscles, right? We often think of like if you're a bodybuilder, I need to get like 16,000 calories to get big, right? But it's really brains that take a lot of calories. Brains will take about 6 to 8 times as many calories per cubic centimeter or per gram to fuel. Your brain takes a lot of power. And this is going to become one of the key drivers in our story of human evolution is how do we get more calories out of the environment? If you're a gorilla eating raw fruits and leaves and berries, you pretty much, and you spend pretty much every waking moment of your day nibbling on something, you've pretty much maxed out your caloric capacity for the day without what? Ambition. Yeah, they're not very ambitious. Kind of wish I was a gorilla, just like hang out all day with the family and eat things. That might be nice, but what's a way we could unlock maybe more calories from our environment?
Wider diet.
Wider diet, and that's what these Australopithecus are doing, right? These gracile ones, especially the robust ones, are maintaining basically a gorilla-style diet, so we can tell by their big chunky teeth. Oh, some of this around there. Basically, these guys figured out that by eating scraps left over from these kills, you don't have to kill it yourself, which is nice, right? Like you don't have to be like these are people, creatures without tools or anything like that, without fire, without spears. Hard to take down an elephant, but if someone's already done it for you, right, you can come by and clean up the scraps. The meat's going to be a lot more calorically dense than just eating plant stuff. And basically throughout the next couple of weeks, we're going to kind of be returning to this issue of how to get more and more food calories out of an environment, whether it's stone tools, so as you crack open those bones and get to the tasty marrow. Next week, we'll talk about fire. Cooking your food gets you more calories out of the same piece of food. Or in a couple of weeks, we'll talk about agriculture, planting corn or having a cow as your pet / food, right? It's going to give you more energy from the environment. So this kind of constant story of getting more and more energy out of your environment. Originally, we have some of these kind of basal Australopithecus, like Lucy, when the tongue child, the Anamensis and Afarensis. But by about 3 million years ago, we start to see this split, right? 2.5, 2.8, between the robust Australopithecus. These guys like this is a Boisei, but kind of indicative of a robust. He's like the most robustest of the robust, right? So I picked him. This is the looking guy. Who's broadly comparable to gorillas, right? You'll see the teeth are very similar. You'll see they have the sagittal crest on top, a pinch, big brow ridges here, a pinch behind the brow ridges, the small frontal cortex, relatively flat versus our skull, right? It's going to kind of dome up behind your eyebrows. This one basically just goes straight back. Big holes right here. Muscles coming up from the jaw, attaching to this bony crest right here. Lets us know they're eating a lot of tough stuff and eating a lot of muscles, right? These are, I'm going to send this around with my gorilla just so you can compare. These are over here. This is this right line. What do you notice about this timeline of this creature's over here on the right? These are basically the various robust, Boisei, robustus, and Aethiopicus. What do you notice about the time period? Are they alive today? No, they're not. They are all extinct, but yeah, they've been around, they seem to go around, both kind of all disappear about 1 million years ago. So maybe something happened either climactically or in relationship to these other creatures, these other early humans. Maybe they hunted them out or outcompeted them. But they are co-contemporary with the, not only just other Australopithecus, but early humans, right? Homo habilis and even like Homo erectus, right? And one of the kind of the reoccurring themes that we're going to see over the next 2 or 3 weeks in this class is there was a very long time where we as humans, like humans, Homo, shared the world with a bunch of other weird creatures who are like very close to us, right? We think of chimps as our closest cousins, but these are things that are like very close to us, right? And that we often shared not only like a continent, but often interacted face to face. And we'll talk about this, especially as we get to like the Neanderthals and things like that. How did we interact with these creatures? Did we fall in love and marry them? Did we fight them? Did we kill them? Did we just ignore them, right? People have lots of theories, but co-contemporary with these Homo habilis, who we'll also talk about today. So again, very late in kind of prehistory, 1 million years ago. Seems like, oh, it's a long time ago. But this is well after the time period of people using stone tools. And there's questions about if did they use tools, did they use, what kind did they use, and maybe some of these other characteristics that they had. I'll show you some quick pictures about them, and then we'll move on to Homo habilis. Here's some robustus. Here's some robust Australopithecus. Again, you can kind of just, these are reconstructions from like a textbook, right? Bipedal apes, kind of eating things off of the landscape. Again, Raymond Dart, the guy who discovered Pong and Africanus, also discovered some of these early robustus about 2.5 to 1 million years ago. Again, in East and South Africa. They lived at the same time as our human ancestors, but they did not go on to have descendants who are around in the modern day. But they are interesting. Again, the teeth are really different. I'm going to send around the Africanus as well. And you're going to see the difference in the gracile versus the robust and how different their teeth are. These are just giant teeth. I mean, especially with the Boisei. There's really no doubt about what they're doing with those big flat teeth, right? They're not eating meat with those. They're grinding some kind of planty thing. Even though they're called robust and gracile, these Australopithecus are, in terms of brains and bodies, are pretty similar, right? They're about the same height and have more or less the same brain size, right around, bigger than a chimp, but still relatively small. This is afarensis. They have broad cheekbones, big brow ridges, large teeth, flat faces, and oftentimes sagittal crest, that like bone mohawk looking thing on top of the head, which tells us what? What does that tell us if they got that? Sagittal crest. They're eating what? They're eating tough things, so they gotta it's like working out at the gym. They got giant muscles that connect here. Yeah.
Like a tree branch.
Yeah, like branches and leaves and roots and things like that, right? And this again before the days of fire and cooking. So have you ever eaten like a raw potato or tried to eat like a stick or something like that? Yeah, it's going to take you just a long time to process it. You're going to spend a lot of energy doing it and not getting a whole lot of like caloric return. Yeah, Boisei, Aethiopicus, just some general and robustus, right? One of the really interesting things is there's Raymond Dart and others have theorized that these creatures are probably also tool users, right? This is again, he came up with this idea before Jane Goodall discovered chimpanzees were using sticks as tools. So this is like back in the 30s, and she didn't discover that in the 60s. But he hypothesized that they were using what's known as, I don't have my picture. I have one. Where is it? Oh, there it is. What's known as osteodentoceratic? There's osteo means what? Bone, donto, teeth, keratic. It's a hard one. Keratine is in what? fingernails, horns, things like that. So using tools, while not using stone tools, we don't see really a lot of any evidence for that among the robust, but possibly, bless you, using tools of bone, of horns, of teeth, and things like that. And we can actually see this now. There's a really interesting study that people have found. Here's my picture. Pieces of bone that seem to have markings on them. And so people have done like experimental archaeology. Some people have theorized that while chimps use sticks to like poke holes in termite mounds and take it out with termites on it, even like a termite popsicle, that only works in the rainy season when those termite mounds are like muddy and you can stick it in. In a dry season, your stick's not going to do anything. It's going to break off as you try to do it. So they have hypothesized that maybe during dry season, these creatures are using bones or pieces of bones or horns to like poke holes in termite mounds and get termites out, because they find these weird bones with scratch marks all going in the same direction. So people doing experimental archaeology basically take pieces of bones, take a termite mound, jab it 100 times, and then you look at it under a microscope and you can see that these patterns are broadly similar, right? So these bones seem like they're being used for tools, but again, it's debatable. Okay, so that's one side of, you know, the robust guys over here. But really, this class, we're interested in us, right? We're kind of looking at the origins of human diversity. And so it gives me great pleasure to finally move into us, Homo. There we go. And Homo is our genus. We are Homo sapiens, right? So we're getting really close to who we are. Just beginning about just a little, right around 2 million years ago. There's some question, maybe it's a little bit earlier, like 2 point something, right? We see the emergence of a new species, Homo habilis, which seems radically different from some of the Australopithecus, which came before. They have pretty big brains, right? In terms of, compared to Australopithecus, we're talking about like, I got a better picture over here. Where is it? There we go. No, it's Homo erectus. Habilis. Here we go. In terms of, Africanus, the gracile skull that's going around, it's about 430 to about 520 cubic centimeters. Again, chimpanzees like 350. So this would be like way smarter than any chimpanzee, but we're somewhere like 1500 to 1800 cubic centimeters. Homo habilis is a remarkable step forward in terms of brain size, going from about 430 to 520 to about 600 to 800 cubic centimeters. And you might be like, that's just a couple hundred cubic centimeters, but it represents almost a doubling of size of your brain. What do you think you could do with more brains? A lot of things, right? You could be human, do all the human kind of things, right? And we see the beginning of a lot of these behaviors, which really set us on the path to where we are today. In addition, I'm going to send this one around as well. This is my Homo habilis skull, KNM-ER 1830 before. When we look at these, right, in terms of, you can compare this one. Where's the Australopithecus, the gracile? Okay, now the gracile one. Okay, yeah, you can keep those. Good for comparison. I'll give it back. So I'm going to pass these two around together as a set. You can see Homo habilis, a lot bigger brain than this one. But in addition to just being bigger, it's got some other features, right? This one has what's called post-orbital constriction. Right behind the eyes, it's like pinched. You can see I put my finger, my thumb, and my finger right here. Versus on a Homo habilis, not nearly as much pinched. More going on in the front of the brain. What goes on in the front of the brain? It's the frontal cortex, all about memory. Decision, memory, sense of self, cognition, and emotion, problem solving, right? Yeah, all that like human stuff. All the animal stuff is going to be on the back and underneath and all that, right? But we're really developing the human parts of our brain. And you'll see this on top as well. This one does have kind of a rise here, but this one comes up more round, more globy. Smaller teeth, Right, these bones are thinner, they're less thick, and the front teeth and the back teeth are becoming more the same size versus this one still tends to have kind of these big chompers in the back. Here, I'll pass those back here. So something remarkable seems to have been going on. There's not a ton of fossil evidence right between 3 and 2 or 2.5 and 2 million years ago. When all of a sudden we tend to see some big changes, right? Boom, boom, boom. About 2.3 million years ago. Again, not just replacing Australopithecus. A lot of these Australopithecus seem to hang on, especially these kind of robust ones. But while the gracile ones tend to get, evolve into this Homo habilis or get replaced. Differences in face, differences in teeth. But again, post-cranially, right, beyond the body, we're still relatively the same, right? Still bipedal, still doing the same kind of things. I want to show you a video, 8 minutes or so, and then we're going to talk about Homo habilis is both physically as well as culturally remarkable, right? And this is again exciting for me as a cultural anthropologist. Like, oh, thank God we're out of bones and teeth and things that are not my specialty, and we're on to culture, thank goodness. So we do see this big brain, and probably they're having more complex thoughts and problem solving. And what's one way we can actually see that maybe in the archaeological record? The remains, but also the stuff that they make. Yeah, we're going to talk about some of the tools, and again, you're going to have a chance to take a look at. So I'm going to show you, we have 20 minutes left, plenty of time. I'm going to show you a little bit of a video about Homo habilis, and then I'm going to talk to you a little bit about some of their awesome tools, especially their stone tools. So I'm going to pause this, and we'll jump into. Hope you enjoyed that video about Homo habilis. A lot of facts for you in there. Some important ones. It was discovered in 1964 by Lewis and Mary Leakey. We've heard of them before. Where did we hear about Lewis Leakey before? Yeah, funded Jane Goodall, Diane Fossey, and Bayrute Gallicus to do their study of modern living apes, right? Because he was really interested. He was finding old fossils, and he wanted to kind of compare what they were capable of with modern apes. So we heard him again, and we're actually going to hear about his son, Richard Leakey, next week with the discovery of Homo erectus and Turconaboy. So famous family in paleoanthropology. Yeah, Homo habilis comes from the Latin handy man, right? And they got this because they were the first creatures in our human line which have been found with stone tools, right? And this was, again, this was kind of the line that Lewis was thinking of when he had Jane Goodall go to the jungle and look at chimpanzees and their tool use, and he was kind of looking at how these early fossils might use it. Because not only did they find the bones, but for the first time, we're actually finding cultural artifacts. We're finding rocks along with them, right? And again, like I said earlier, this is going to allow them to get more resources out of the environment, because if you, right, we've already talked about that kind of gracile Australopithecines taking that step to not just eating plants, but being very omnivorous and getting more out of their environment by eating meat. But there's only so much you can do if you're a scavenger, and the lions and the hyenas and the vultures have all taken their fill. And so stone tools, people theorize, is these are not like bow and arrow or spears or swords or anything like that, right? These are scavenging tools. How might having a sharp rock like this, right? They don't look like much. They are broken stones, and people, like a lot of students, they're just broken stones, right? But they seem to be broken in a particular kind of way, and we're going to learn about that more on Friday. What could having a stone that's round and soft on one side or not sharp on the other side, and having a sharp edge on the other side, how might that make you a more effective scavenger? Hey, you can cut things, right? You don't have to like use your teeth to tear off the meat. What else could you do with those rock tools?
Cut wood.
You can cut wood. You could cut from eaten meat. Hides. You can break bones. That's what people think they're called, right? Your bone, if you ever look at it like a long bone, it's got a hole in the middle. It's got like an empty space where the bone marrow is. A lot of times, those big predators are not going to eat that. They're going to eat the meat because that's really easy to get to. It's hard to break open bones. And you'll see some kind of carrion creatures like hyenas or jackals will do that. Vultures will sometimes snap open bones, but it's not very efficient to do with just your mouth. But having these tools, especially for our early ape early Homo ancestors, really opens up the buffet, so to speak. And again, we find these right around the same time. So here's our hominin family tree, our ancestors and our cousins. And about 2.5 million years ago, we're not only dealing with skulls, we start to see different types of tool technology. The very first one that we see about 2.5 million years ago, which seems to be kind of co-contemporaneous with the emergence of Homo habilis, are these Oldowan tools. People have theorized that there's this like feedback loop as they're able to get more calories from their environment. The brains get bigger, and then as your brain gets bigger, you're able to make bigger tools, and then you're able to get more out of the environment, and back and forth, and your tools get bigger. We'll look at Acheulean hand axes with Homo erectus, and then some of these really late ones, which are just phenomenal works of art. We'll see. Making an Oldowan chopper is hard enough, and these things are just phenomenal, right? When we see these, there's actually like a set kind of pattern, and Dr. Asher will be in here, right? I'll give you some pointers on how it works, but in general, like you start from a rock cobble, spin really round, and you're basically leaving one side rounded, so you can keep it in your hand, it doesn't hurt you. Hit it, and then you're taking off flakes, pieces from the core, and making a sharp edge. Originally, the super basic form, usually it is one big cobble, either with one side, right? I'm taking pieces off one side, uniface, or I'm taking it off both sides, which is a more advanced technique. We'll see later where you take it off this side and you flip it over and take it off this side, a biface. But generally, these are pretty basic. And as we go later, people will start, instead of using the big cobble as we get towards like Neanderthals and modern humans, we'll use those little flakes and start to make things like arrowheads and spear points and stuff. But basically, you're taking what's called a hammer stone or a rock, you're hitting it with another rock. You can also use softer things, especially for like touch-up work or for making more precise things. You can use antler, you can use sticks, use bone and things like that. So it tells us a lot of things, right? It tells us these creatures were getting more out of their environment, but what it also tells us is that they're planning, they're thinking about these things. These tools are made remarkably similar, right? There's like a long period of time, almost 1 million years or 800,000 years of using the same basic kind of tool. And they're remarkably similar across a very long period of time, like, which is amazing because, if you look at like a car that was made in the 1950s and today, they look pretty different, right? Or an airplane from like the 1920s versus the 2020s, right? 100 years, they look completely different from the Wright brothers to our modern airplanes. But about 800,000 years of creatures basically doing the same kind of thing. What's really interesting about it to me is that when you make these things, you have to have an idea before you start, right? Probably the first one that found a broken stone, it's like, oh, I can use this, right? But pretty quickly, once you start to make these, there's a definite pattern, and you can actually trace it. You can see on here, there's like numbers, right? This is step one, you take a big chunk off, then you take number two, and you take smaller pieces, and then you work your way around the core until you have something kind of sharp and spear pointed, right? And this seems to be the pattern. So it means that these creatures were not only like thinking about it and planning these things beforehand, right? I'm going to make this into a stone tool. I'm going to pick this rock and not this rock because this one has like an occlusion in it, which is going to break, and this one's much better. Or say different kinds of rock, right? We're going to look at, we're going to have chert and we're going to have obsidian, which we can use on Friday for our experiment. But if you use like sandstone or something, it's not going to work, right? It's going to be terrible. So people are learning about their environment. These creatures seem to have rock quarries or sources where they would go back to and pick good rock, right? Like we probably like, oh, rocks, who cares? But if you're a stone tool maker, you pay a lot of attention to what kind of rock. So traveling, I think I have this over here, right? 10 to 20 kilometers, so like what's that, 15 miles from a home base. or from where you're set up to go get this rock, which is really interesting, right? We see this. It shows knowledge of materials. It shows knowledge of how stone works, right? Like they have this idea of fracturing, and then if you hit it at a certain point, you'll see this when we do our experiment on Friday. You have to, if you want to take a flake, like this was a rock, you're going to take this flake off, you have to hit it over here, right? You have to kind of imagine where you're going to hit it and what's going to happen. And you'll see it's way harder than it looks, right? We tend to see them for food processing, but like I think as Corbin said, we can also see them used on like wood or other things like that, or even bone to make other tools, right? Tools that make more tools. It seems to be that like they would take kind of cores or just take rocks and then fashion them. But we often find them one of the reasons that we know what they're used for is that they're often discarded when they break or when they're done using them around animal bones, right? So we found I had a picture of like we'll find a skeleton of something that they're processing, and then we'll find either flakes where they'll like, oh, I broke my stone tool, get my other rock out and I'll touch it up and make the edge sharp again. Or this one broke, throw it away, I'm gonna get myself a new rock, right? So it tells us they're used oftentimes in association with it. People have also talked about maybe they have some kind of home base or some kind of camp. I don't really buy the hut kind of argument that Mary Leakey makes. We'll see that kind of more with Homo erectus, but they do seem to have like home bases or ranges, it maybe seems like places they come back to. So I'm going to come here because it's a watering hole and there's some stone over here that's really good. And down here in the gorge or in this valley, right, there's animals down there and I know I can hunt them, or they come to the lakeside and I'm going to hunt them. So they seem to have this kind of area where they roam around on the savannah. And so next time, like I said, on Friday, we're going to, we can meet in here and then we'll go out back. Remember to bring your long pants. I'll wear long pants for the first time this semester. Closed-toed shoes, and if you have sunglasses or eyeglasses, we don't want any pirates over here at the end of class with the eye patch. Jose and I will be there with Band-Aids just in case. Hand them out, right? But we have leather gloves, and we have the stones, and we have the hammer stones and the sticks and all that you're going to need. And so, yeah, you'll get to see, right? You look at this, you're like, yeah, it's so easy a caveman can do it. But we'll find out on Friday if you are, in fact, it's like that old show they had. Are you smarter than a fifth grader? Are you smarter than Homo habilis, right? Okay, that's all our time for today. I'm just so excited to get to culture finally. It's been weeks of talking about bones. But yeah, from here on out, we are talking about culture. Thanks for hanging out. See you on Friday for making some stone tools.
We did it Monday.